Hi, here's my tutorial video about selected topics in properties of solutions and thermochemistry. Here are some examples of ways of expressing concentration by molality. In this problem, we can see that the given values are already satisfying the formula of molality, as it looks for the moles of solute and the kilogram of solvent, so we just have to substitute the value. And it's 0.76 mole per kilogram. But that's not always the case. Some problems requires conversion before you can actually solve. In the second problem, we can see that both the given values are grams, which means we have to convert before we can solve for the molality. The grams of sodium chloride should be converted to mole of sodium chloride, and the 700 grams of water should be converted to kilogram of water. So here is the conversion. First, we find the atomic mass of the compound, the sum of the atomic mass, the mole. Then we converted the grams of water to its kilogram. After the conversion, we can now solve for the molality. That's mole of solute divided by the kilogram of solvent. Let's proceed to the boiling point elevation. A 30.25 gram of sodium chloride is added to 200 ml of water at 35 degrees Celsius. How will this affect the boiling point of the water? The density of water at 35 degrees Celsius is 0.994 gram per milliliter. And the value of molar boiling point elevation constant in degrees Celsius kilogram per mole is constant, which is 0.51 degrees Celsius kilogram per mole. To find the temperature change elevation of a solvent by a solute, use this equation. The first step is the calculation of molality of the sodium chloride. From getting the sum of the atomic mass of the compound to calculating its mole, then the molar boiling point elevation constant in degrees Celsius kilogram per mole, which is multiplying the density by the volume. After that, we can now solve for the molality of the sodium chloride. That's mole of sodium chloride divided by kilogram of water. 0.52 mole divided by 0.199 kilogram is equals to 2.61 mole per kilogram. The step 2 is determining the Van Hoff factor. 1 is constant for substances that do not dissociate in water, and 2 is constant for solutes that completely dissociate in two ions. Example is the sodium chloride, which completely dissociates into two ions. The last step, the step 3, is finding theta T. Theta T equals to I, or the constant, times the molar boiling point elevation constant in degrees Celsius kilogram per mole times the molality of the compound. That is equals to 2.66 degrees Celsius. Therefore, adding 30.25 grams of sodium chloride to 200 ml of water will raise the boiling point by 2.66 degrees Celsius. Thermochemistry. Calculation of work, heat, and internal energy. In solving the heat, work, and internal energy, we have to first identify the given and the formulas to be used. Heat is constant temperature multiplied by the constant external pressure, and that is negative 267.6980 degrees Celsius.